Hello physicists and welcome. In this session we'll cover supplemental topics in graphing. Our learning objectives are: I can determine the slope of the best fit line by linear regression, and I can identify power and reciprocal best fit lines. Let's get started. Hey, so slope by linear regression, what does that mean? Hey, so if I've got an x and y axis and I've got a set of points here, a point 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 here. Maybe I got another point here. I've got properly labeled axis here. What I'm looking for is the line that will, put another line here. Okay, let's go straight line. The line that best represents all these points. It goes in the direction that the line that the data goes. It's as close as we can get on average to all of those. And how is it determining that? If you want to know the real fancy thing, it ends up looking at the distance that each of these lines is from the best fit line and tries minimizing that distance. Even fancier, it minimizes the square of that distance. That's what meant by a linear regression, or a linear regression by least squares. Hey, you can take a look here at how you might do that using your fancy calculator. Want to know why you spent all that money on that graphing calculator? This is why. Hey, so I've listed the steps that you need to do that. In just a few moments, I will actually take you through a little demonstration here. The graphing calculator can be used to determine the line of best fit, particularly for a straight line. Show you how to do that here. I'll use the statistic function, and you'll see I have three options across the top: edit, calculate, and test. We'll use edit to populate our list. So I'm already at option 1. I'll hit enter, and I have two lists. L1 will be my independent variable. In this case, it'll be the temperature data. L2 will be the ant activity data. I'll enter that. I'll put a 0 in here and enter. 10. I won't bore you with the details. I'll pause for a few moments to finish entering in the data. We can use the arrow keys here to navigate from list 1 to list 2. The two lists are complete now. I want to plot those. I'll go second function and start plot. See, if plot 1 is off, I'll select that one. I do want to turn that on, so I'll toggle on over to on, enter. I want to have a scatter plot. You can see that here. If I wanted a different plot, I could toggle over to those. My X data, or horizontal independent variable data, will be my list L1, and my Y, or vertical data, will come from list 2. And if you want to pick your spots, you can here. All right, so I'll go ahead and enter that and graph that. May not get much here. We'll have to adjust our window. So we'll go from 0 on the x-axis, and it looks like, let's see, we'll toggle on down here. A good maximum value looks like it would be about 50 there. On the y-axis, we'll go from 0, and it looks like if we go down to about 100 there, that'll cover it very nicely. Let's take a look at our graph. Okay. Hey, we see our data points here, but there's no line in there. Let's go ahead and figure out what that line should be. We'll come on back to stats. Now we want to calculate that line, so I'll toggle on over to calculate. See, I have a list of various things here. Option 4 is my linear regression. So I'll toggle down to number 4, linear regression, hit enter. Okay, and one more time to actually calculate the value. All right, so you can see it's presented in the normal format of a line: y equals ax plus b, in slope-intercept form, where a is our slope, 2.0, and a bunch of numbers. B is our y-intercept, 1.97. All right. Hey, so now let's go ahead and put that line on our graph. Let's go back over here. We'll have y equals. And y equals, kind of a quick way we could do that. We could type in that equation we just figured out, or we can come down here over to variables. All right, and we'll look at our statistics we just figured out. Toggle on down to number 5, enter. We're going to see what we have as an equation for that. We figured out that equation for the line. There it is. We'll hit enter. So we've entered in our values for y1. And let's come on over here and graph what we have. Let's see what we get. We get our points and our line of best fit based off of a linear regression. So I produced a graph here of the same data that we looked at with the calculator. We see that we have our independent variable, the temperature from 0 to 45 degrees, our ant activity from 0 to 90 ants passing a particular point every second. We've produced a well-labeled graph. I have a variable, or independent variable, along the horizontal axis, also known as the x-axis, with its units, degrees Fahrenheit. Along the vertical axis, our dependent variable, labeled ant activity and its units, ants moving past a particular point every second, and then the data point, our ordered pairs, are placed on the graph. Last thing this needs is really to put the same linear regression best fit straight line on the graph that we did with the calculator, just in a little more presentable form. Let's go ahead and do that. I've now added in here the best fit line for the data that we have here. It looks the same as you saw on the calculator. A couple important points to note here is the best fit line does not necessarily pass through any of the data points. It may run fairly close to them, okay, but it does not necessarily run through any of the data points. The other thing is it shows the general trend among the independent and the dependent variable. In this case, we see as temperature is increasing, that ant activity is also increasing. So we'll refer to this as a direct relationship. Now, early on, most of our relationships will be some type of a linear relationship between the independent and dependent variables, but we will encounter other ones that aren't quite a straight line. Here's an example. You can see here that if I were to give some type of a straight line, do I pick these points here? Do I pick these points here? It becomes difficult to determine some type of a straight line. If I were to pick a straight line through all this, all the data in the middle would be on one side and all the data at the beginning and the end would be on the other side of the line. This gives us an idea that there is a more complicated relationship. And you may be starting to look at these in your math classes. This would be best represented by this line here. In this case, this follows a function that looks something like y equals ax squared, a power function, or also known as a polynomial. And the special shape that this makes is known as a parabola. So sometimes if we end up having these curves in a certain shape, it's because we have a special relationship that's not a linear relationship, but something that has a more complicated relationship. Hey, the other type that we may end up seeing is something like this, where obviously as I increase the value of the number of people, let's take a look at this one here. We have, what do we look graphing here? Let's see, it's a 2-pizza feeding frenzy. We want to know how many slices per person versus the number of diners. So what we've done is we've bought two pizzas, and we're checking to see how many slices per person we can get with different size groups. So my independent variable, the number of people, is plotted along the x-axis, and the number of slices that each person can have if we were to eat all of these two huge pieces. Looks like each pizza has 32 slices to it. All right, how many slices each person can end up having? Again, we end up seeing that there is some type of an inverse relationship, because as the number of people increases, the number of pizza slices per person decreases. But again, in this case, do we pick out, a straight line here? Do we pick out a straight line here? Maybe all the way out here? And if we were to look at this a little more closely, we see that really none of those lines really fit it very well. And there's a special relationship here. If I were to plot this, I end up finding that, hey, there's this special curve that follows something that looks like y equals maybe 1 over x, could be something like that. But you can see here, as x gets larger, y gets smaller, and vice versa. When y is very small, x must be very large. So this could also be, maybe a particular number, a over x, or if we're looking at something really fancy, maybe it's going to be equal to some constant. I'm going to call it b in this case, over x squared. But again, something that has a very characteristic shape that it continues to curve, and this is referred to as a reciprocal relationship. All right. Hey, this covers those advanced topics. Let's see if we quick check, see if we do this with our supplemental topics in graphing. Can you now determine the slope of a best fit line by linear regression? And can you identify power and reciprocal best fit lines? We're not looking to find out, can you calculate that value, but can you identify that it's either a power function or perhaps a reciprocal function? All right, that's it for now.